to a Talk IT tutorial. So this is C++ Mesh Model Viewer, and we're going to be doing Lab 5, which is keyboard and mouse input. This is quite crucial to our application. It allows us to go around the mesh model, and then the keyboard allows us to interact with it to do things. So to start off with, what we're going to do is implement camera movement using something called an arc ball. So the idea of the arc ball is at the center of this sphere, which is this ball that encompasses what will be our bunny. The camera moves around the circumference of this circle. Effectively, it means it's the same distance and it's always looking at the center of this sphere. I've included some links here that go over the sort of mathematics behind it and some theory behind it. I'm going to go straight into the code. I can't really do it justice. I don't fully understand the mathematics behind it. I can just sort of implement the coding behind the mathematics. To start, let's include math.h. We need this for our math operations. So go straight to the top, just include that. Include some variables. So we've got Windows width, Windows height, theta and phi, and then r, which is going to be our radius. So then copying this into our mouse move function that we created earlier, which is here. So we take in x and y, so this is the movement in the mouse in the x direction or the y direction, so left or right, up and down. We get the window width, window height. So then theta is 360 divided by the window height times the y direction times the three possible rotations that we've got. Then we restrict that within 360 degrees, which is obviously the sphere. We have to convert what we've done in degrees through to radians, so that's using this factor here. That's just a standard. So then this calculates the ix, iy and iz, so this is where our camera should move to. And then we also obtain another point along the same line, but we reduce it ever so slightly. And then what this allows us to do is just create some temporary ones, and then allows us to work out our up vectors for our camera, so it's always looking at the center of the sphere. And then what we do is a post redisplay, so we say, okay, mouse has moved, I want you to redisplay because things have now changed. So that's that, simply enough. I'll probably show you that at the same time as when we do the keyboard. So adding in the functionality to the keyboard to rotate the cube. So this is quite a lot, to be honest, in here. So what we're going to do is, to start off, we're going to have a rotation boolean. So this just sort of says like yes, I want to rotate or not. And what we're going to do is just sort of say 0 is not spinning on the axis, and then 1 will be. So let's do the keyboard. So this is our keyboard function here. Okay, keyboard. So switch on the key. So case 27. So this is the escape key. That's just its encoding in this. So R, which is the stop rotation, will go to 0 and it will reset the cube. We still need to build that. So on the case X, it resets it, and then it will set the rotation boolean to X, Y or Z. So that's depending on which way we want to rotate it, and then we redisplay after that. So let's create the reset function here. So I'll just probably put that at the top because it's sort of a utility one. Effectively, this is our original cube vertex here. So what happens is this here will get manipulated by our spin function, but we always keep a copy of that effectively. And then when we press reset, all we do is we load in the cube vertex to have the cube vertex original ones. And it's just that simple. Just reset the array. So now we need to create the spin function. So the mathematics behind it here, so how the rotation, there's a matrix that we use for the rotation. So you can find that there. And then this is the variable that controls the speed of the rotation. You'll find that you need to change the speed of the rotation quite often. So when it's not loading or rendering much, it will spin quite fast, but sometimes you do need to up that a little bit, otherwise the rotation can get quite slow. So let's do our spin cube, and then I will run through what it means. So I'll just probably put it just above draw cube. So spin cube takes in the chart spin mode. So this is our X, Y, or Z. Just get rid of those. Okay. So what it's doing is, so you're doing it on the X, Y, and Z. So we've set up some matrices here. What these matrices represent is the rotation matrix on X, Y, and Z. So again, look at the Wikipedia page I provided. It should give that mathematics for you. Then what we have is, on the case of X, Y, or Z, it then will use that matrix. So depending on the matrix that you need to use, so matrix X for X rotation, matrix Y for Y rotation, and matrix Z for the Z rotation there. Just going to neaten this up a little bit. Case Z. There you go. So depending on which rotation matrix we use that one. This will manipulate the values that we're doing. So this will, as you see, manipulate the matrix cube vertex as I said. So then when it builds and it draws that cube, it uses that matrix. So what we're not doing is holding these temporary values. We're just holding an array for the cube that we then use to build off. And then all we need to do is to add this to our display function, which should be near the bottom. So then we do spin cube rotation boolean, which is obviously can be controlled from the keyboard. And that is that, and then we just need to press play and watch it run. So, yep, okay. So that's that at the moment, and then you can see it spinning around here. So this is me, I'm pressing the left mouse button down, and I'm just spinning it round. Just spinning the cube round like that. Now, if I then was to press the X button, it's rotating on X, Y, and then Z. It's quite fast at the moment. That's because it's not needing to render too much. And then if I press R, it'll reset everything again. Okay. I hope you've enjoyed that. I hope you continue on to the next lab. Thank you very much.